So first off, you'll want to head into the Google Classroom. Let me get back there so that when I share my screen, it makes sense. So you're going to head into the Google Classroom. Right up at the top, Robert Clary, that's me, posted a new assignment, numbers as operations. When you open this, I'm going to pick on Addie because Addie's been picking on me all day. Open this one up, and then you'll be able to take notes in the various slides just by double clicking. And oh, look, Addie's already got it open. So there you go. So make sure you have that. Make sure you follow along. I had over half of the people yesterday not turn this in. All you are doing is following along with what I do, writing in the notes and then turning it in. So this is like the freest points you're ever going to get in a class. So please don't not do them. Also, hey, look, Don's here. Cool. So please make sure you have this ready and available so that you can take the notes. Those of you that just got here, it's in the Google Classroom. I'll go through it one more time because there are a lot of you that come late, which is why I usually wait to start class, Jasmine. So right here, numbers as operations, click on it. You'll just have one of these. It won't show you everybody's because you're not the teacher. And then you'll be able to open it right like this. And you'll have a little slide that you can follow along with what we're doing today. Right? Please do this and turn this in. I will make it an assessment if I keep getting this few people doing it because this is ridiculous. It's literally just taking notes. All right, let's actually get started. So today we're going to talk about numbers as operations. The first thing I want to ask is, what do I mean by operations?
Operation, surgery.
No. What's an operation in math?
10 times 10?
Yes, but the actual operation itself is like the multiplication there. So basically, we're rewriting numbers as different operations of numbers. So like multiplication problems or addition problems or something like that. Now, part of the reason for this is a little complicated to understand, but I'll go ahead and start talking about them this way. So first of all, actually, can I have a volunteer? Does anybody who has a mic that wants to volunteer really quick?
Me.
Okay. Jasmine, what's something you're really good at?
Making TikTok videos.
Okay. Were you good at making TikTok videos the very first time you ever tried to?
No.
No? What did you have to do to get good at it?
I had to update the app a lot and get lots of pictures.
Okay, TikTok might not be the best example, to be honest.
I have one.
Okay, Addie, go ahead.
Soccer.
Soccer. All right. So were you really good at soccer the first time you stepped on a field?
No.
No. What did you have to do to get good at it?
I had to practice a lot.
You had to practice a lot. Good. And when you're at practice, do you do drills that are like really basic and simple, like basic footwork drills and basic passing drills? Why do you do that?
To get better at passing and dribbling.
Right. So you have to practice the basics in order to learn new stuff and to get better as you go. Even the really great soccer players or really great football players like a Mr. Tom Brady we were talking about earlier, they all practice the basics anyway. So we're going to look at kind of practicing the basics, but we're also going to start to think of a different way of doing some of them. So instead of just being like, all right, well, with 3,000 times 47, you could type this into a calculator, bam, you'd be done. But we're going to look at how to solve problems like this in your head instead. Now, at the end of today, I don't necessarily expect that you'll actually be able to do problems like this in your head, but we're going to talk about how you can do that, and hopefully you can at least learn something from this, get something going forward. The way we're going to do this is by breaking down problems and numbers into simple enough parts that it's fairly doable. So first we'll break down the numbers, and then we'll look at breaking down some of the problems. So let's start really simple with this. Let's look at the numbers 40, 300, and 2,000. And I want to break them down into multiples of 10. So hopefully you all remember yesterday, we started by multiplying by 10. So we would move the decimal to the right if we were multiplying. We'd move the decimal to the left if we were dividing. Today, what we're going to do is we're going to start out kind of similar, but we're going to write numbers as multiples of 10. So can anybody tell me what 40 is as a multiple of 10?
40. It's 4. No, it's not.
So I'm going to have a times 10. What number goes in front?
4.
Yeah, it's just 4 times 10. What about 300?
It's 10 times 30.
It is 10 times 30, but we can break 30 down further too. So 30 times 10, but we can break that down into even smaller steps. Does anybody know what those are? Candler's got the first number, 3 times 10 times 10. Exactly. So basically what this would tell us, for the first one, we'd multiply the number by 4, and then we'd move the decimal point 1 to the right. The second one, we multiply the number by 3, and then we move the decimal place 2 to the right. So what about 2,000? How do we break that down into just multiples of 10? Yeah, exactly, Jessica. So 2 times 10 times 10 times 10. Does this make sense? Any questions about how to do that right there? Now we could also say this is just 2 times 1,000, but 2 times 10 times 10 times 10 is kind of the full breakdown. All right, now that's a little bit easy, but let's try using it in some actual math problems. So don't just do these just yet. First, what we want to do is break down the numbers. So we're going to have 9. What is 30 as a multiple of 10? We already did kind of
3.
similar. 3 times what?
10.
Times 10. So what is 9 times 7?
27.
Or sorry, 9 times 3. It is 27. Then we have a times 10. So all we have to do is move our decimal 1 point over. So we have 270. All really simple numbers. What about 7 times 200? What's 200 as we break that down? You could just do 100, but we'll do times 10 times
Do
10.
we even have this slide on our thing? I don't think we do.
Do you not? Addie, do you have a question?
I'm very confused.
Well, I was going to say with that problem, you could have just done 7 times 2 is 14, and then you would have added the 2 zeros and got 1,400.
Yep, exactly right. So 7 times 2 is 14, and then we'd move our decimal place 2 to the right. So we're going to have 2 zeros and get 1,400. And you don't necessarily have to break it down all the way into the tens. I'm just doing it for consistency purposes. But you could break this down into just 7 times 2 times 100. That's just kind of skipping a step. All right, and then 8 times 5,000, pretty similar. We have 8 times 5 times 10 times 10 times 10. 8 times 5 is 40. And then we're going to add our 3 zeros for our 3 tens. So 0, 0, 0, and we get 40,000. So a lot of this stuff.
I don't even have everything written down on the last slide.
What's that, Gracie?
You're going too fast. I don't even have everything written down on the last slide.
Well, you did get here a little bit late, but okay. I'll give you a little extra time. So are there any questions about how to do these kinds of problems? I'm sure some of you already knew how to do this in your head pretty easily. So we're going to get into some more complicated ones in a little bit.
No, but why are you doing this out of order?
What do you mean? Is this out of order on yours?
On slide 6. I'm only on slide 6.
Hold on, let me see.
For
It might be
problem.
That would be weird. I don't know why it would be like that. No, that looks right to me. Should be slide 4.
No, I didn't add slides or anything. I opened it and it was like that.
Oh. Jessica and Addie both said that it's on the right number of slides. So I don't know, Jasmine, but you'll have to keep. Slide 6 has similar ones, but they're different problems.
No, they're the same problems.
Okay. Well, does anybody need more time to get caught up here? Or are we all ready to go?
I need more time.
Okay.
My slide 4 has 1738 and 215 on it.
Then your slides just got jumbled up because that's the next slide. Okay. Go ahead and move on to the next one. So when we break down numbers that are not multiples of 10, because most of the time, let's be honest, you don't get nice little multiples of 10. It's often easier to actually break them down into addition problems. So let's start with 17. What's an easy way to write this as an addition problem? There are a lot of ways, but what's the
7.
easiest? Yeah, so 10 plus 7, a few of you had that. Right, 10 plus 7. What about 38?
+30
Yep.
8.
30 plus 8, exactly. Now we could be really mean and break this down into 3 times 10 plus 8 if you just really want to break these up, but you don't necessarily need to do that at this point. What about 200 times or 215?
200 plus 15.
Yep.
So I'm seeing a lot of this. That does work, but we can go a little bit further than that. Jane, you just put it in chat. That's the one I was looking for. 200 plus 10 plus 5. So this way we've got it broken down. So in every single version of this problem, you're only using one actual number. The rest are just zeros or placeholders. Now, this is something that you actually might have done in like when you were first learning basic, not basic, but like long step addition and subtraction and stuff, where you break it up into the hundreds place, the tens place, and the ones place. But we're going to start actually using this in real math instead. Also, let's see, just shut up. Lily in. Okay. And Lily, make sure you head into the Google Classroom, open up the PowerPoint that's up there or posted right up at the top. It should follow along with this. And I can help you catch up on the ones you missed in a little bit. All right. Now, we're going to try to put this together a little bit. And it's a little bit scary, but try to stay with me. So, first of all, let's break 32 into an addition problem.
30 plus 2.
Yep, 30 plus 2. And then how do we break down 400 into multiples of 10?
10 times 10 times 10 times 10.
4 times 10 times 10.
4 times 10 times 10. Now, here's something really interesting. This way of breaking down problems looks probably more confusing when you're looking at it, but this actually lets you do this whole problem in your head really easily. So what we can do is we can ignore the tens and the tens, right? All these are saying is at the end of our problem, we need to add 2 decimal places, right? Because this says move the decimal place to the right once, and this says move the decimal place to the right once. That's what times 10 does. We talked about that yesterday. Hopefully you all already understand that. So what we really have is 4 times 30 plus 4 times 2. What is 4 times 30? 120. And what is 4 times 2? 8. So that gives us 128. And then we need to move our decimal place to the right twice. So we get 12,800. And we didn't have to use calculators at all. Plus, it's a lot quicker than doing the 32 times 400 and then doing it all out that way. Now, we're going to make it a little bit more confusing with this 15 times 62. I'm actually going to skip this one for a second and go down to the next two. So let's do 200 times 57. First of all, how are we going to break down 200?
2 times 10 times 10.
2 times 10 times, oops. Actually, I'm just going to leave it as 2 times 100 this time because might as well. And then what about 57? How would you break down 57?
50 plus 7.
Yep, 50 plus 7. Now again, this 100 just tells us to move the decimal 2 places to the right. So we're going to ignore it for a little bit. What's 2 times 50?
100.
And what's 2 times 7?
14.
14. So we get 114. We move our decimal 2 places to the right. And now we have 11,400. And ta-da, we found our answer. Okay, what about 30 times 55? How do we break down the 30?
3 times 10.
3 times 10. Now, can anybody think of a shorter way to do 55? We can still write it as 50 plus 5, and that's how we'll do it this way. But any ideas on how you can do a shortcut here? So I guess specifically when we're multiplying. So we're going to ignore the 10 for now, right? Because let's just move the decimal to the right. So we can ignore that. So we have 3 times 50 plus 5. 3 times 50 is 150. But we don't even need to remultiply because we know we're just going to add the same thing without this 0, right? Because they're the same. So basically, when you're multiplying by a number that has duplicates, you can kind of do a cheap little trick where you don't have to actually do the multiplication twice. So 150 plus 15 gives you 165. Then we carry the tens place, add a 0, we get 1,650. Now, 62 times 15 is a little bit more difficult, but what I want to do is talk about the number 15 specifically. So 15, 3 times 5 is one way to think about it, but another way you can do it is, if we think about 15, it is 10 plus 1/2 of 10. Right? What's half of 10? 5, exactly. So 10 plus half of 10 is 15. Now, this probably seems significantly more complicated, really kind of ugly. And then we have the times 62. Now, we could break 62 into 2 parts, so you'd have 60 plus 2, but we don't really need to here. What's 62 times 10? I'll give you a hint. You just need to move the decimal one place to the right. So we have 620. And then we're multiplying it by half of 10. What that actually means is we're just taking this number and adding half of it to itself. So what's half of 620? 310. So what's 620 plus 310? 930. Does anybody have a calculator with them that can really quickly check that?
Yes.
What do you get when you do 15 times 62?
930.
Look at that. So this trick specifically is one that is really, really complicated. If you don't understand it, don't worry about it. You don't need to use it. If you do understand it, it might help you with some other things. So you can do something similar with 20 and 5. You can do something similar with like 21. There's a couple of different ways that you can use a similar trick. It's just one that I wanted to show you all so you could see it. If it doesn't make sense to you or if that's too many steps, don't worry about it. It's not a big deal. If it does make sense, then it's something that might help you do problems a little quicker later. Okay, let's move on a little bit. We're going to look at a really big problem here and make things a little bit more confusing, but we're kind of just going to do this step by step, the same thing we've been doing before. So first of all, let's break down 123. What do we get?
50 plus 50 plus 23.
You could do that. Well, let's break it into its places.
100 plus 20 plus 3.
100 plus 20 plus 3. We're going to write that all in parentheses. And what about 200? What could we break 200 into?
100 plus 100. Or we could do 2 times 10 times 10.
2 times 10 times 10. That's the one that I'm going to use. 2 times 10 times 10. Now, once again, we can ignore this times 10 times 10. We can just bring these out and say we're going to multiply the whole thing by 100. So what we can do here is take this 2 and distribute it to each of these instead. So what we'll do is 100 times 2 plus 20 times 2 plus 3 times 2 all times 100. or written out fully, 100 times 2 plus 20 times 2 plus 3 times 2, all in parentheses, times 100. Now let's solve each part. What is 100 times 2? Oh, sorry, Jenica, are you having trouble keeping up with the writing or just in general?
I am too.
Okay, I'll give you all a second. I think I broke Jessica. Because those aren't
Why?
words. She just typed gibberish into chat. Okay, I don't know what that means. Are we ready to move on, or do we still need more time?
Yes.
Okay, so we did the 100 times 2. What about the 20 times 2?
40.
Yep. And what about the 3 times 2? I see that Jane, you finished it, but I don't. Yeah. So 3 times 2 is just 6. All of this times 100. What's 200 plus 40 plus 6?
246.
Exactly. And then how do we multiply by 100? That is correct, Addie. So we just move our decimal 2 places to the right, add our 2 zeros. So our final answer, 24600. Now, this is one of those rare cases where doing it this way is actually significantly longer than doing it the normal way, right? Like if I just did 123 times 200, multiplying these out, you'd get, 0, 0, 2 times 3 is 6, 2 times 2 is 4, and 2 times 1 is 2. So this is one of those cases where the shortcut's actually a lot longer than the normal one. But the point remains the same. This can help you break things down. Now, where this actually gets really helpful is going to be in algebra. So when you're a freshman in high school, being able to break things down like this will help you reduce problems really quickly. So it is something that will become more useful later as you go. So it's just a skill, like I said, that I want you all to see so that at least you're somewhat familiar with it. Make sure everybody has a little bit of time to write this slide down before we move on to the last 2, 3.
Which one is the next slide? Because mine are out of order and
The next slide should say fractions as operations.
yeah, that's all the way down on my 8th slide.
That is where we're at. We're at slide 8. All right, let's look at fractions as operations. So what are fractions? That's my first question.
Fractions or fractions?
Uh-huh. They are parts of a whole, but what are fractions, I guess, in like a practical sense? So you've got a numerator, let's say 2, divided by a denominator, let's say 3. What is actually like happening here?
You have
2 divided by
Right. So it's a number divided by another number. A number divided by, oops, another number. Or just division, but another number. I can't write. Oh, my handwriting is so, okay, we're gonna try that again. A number divided by another number. Luckily, you will get to type this instead of having me write it out. Now, this might sound a little bit like it doesn't really help you at all, but I'm going to show you why this is useful when we're solving problems. So what this is telling us is instead of doing times 3/4, which is some weird fraction, or converting it to a decimal or whatever else, what we can do is literally separate this into 224 times 3 divided by 4. More importantly, and more usefully, we can write it like this: 224 times 3 over 4. Can anybody tell me why this is more useful? Any guesses?
Because it's a lot easier to do than doing all the bunch of work.
Kinda, but there's something that I can do from here that I can't really do from here. So if I multiply 224 by 3, I'm going to get some really big number, right? And then dividing that number by 4 is going to give me a not as big number, but a bigger number. Addie, do you have an idea?
Oh, I was gonna say you do 224 times 3, then you get your number, and then you divide it by 4. That's why it's simpler, but you said.
So you can do that. That does work. But even easier to keep the number simpler. Like I said, we're trying to think about ways we can do this in our head instead of having to do it all like writing it out in calculators. And you're not necessarily going to have to do problems like I'm not going to not let you use calculators going forward. I'm just saying this helps you kind of break these down. Yeah, exactly, Barbie. You can cancel out 4. So you can divide by 4 right away. So instead of doing the times 3 and then divide by 4, you can just divide by 4 right away. So 224 divided by 4, there's kind of some tricks to do this. If we write it as 200 plus 24, does anybody know what is 24 divided by 4? There's
56.
no, yeah, it's 6. And then 200 divided by 4 is 50. So we can just do this as 56 times 3, which is a much smaller number. And then 56 times 3 is 168. So what could we use for 1025 times 2/5?
1025 times 2 divided by 5.
Yep, 1025 times 2 divided by 5. And again, see how we can just divide this 5 out earlier to make our numbers smaller? So in this case, 5 goes into 25 5 times, 5 goes into 1,000 200 times. So you get 205 times 2, and 205 times 2 is just 410. And then a similar thing with 36 times 13 over 6. 36 times 13 over 6. We can just divide 36 by 6, which gives us 6 times 13. And then we can solve this from there pretty easily and get 78. Now, like I said, once again, this may be far more complicated to you than just doing it out the fancy math way. It might be more difficult. It might be easier. It might help you think about things in the future. This kind of thing will be more helpful later on. So if you do understand it, then it can be really useful. If not, it's not that big a deal. I'll go ahead and leave it like this. We've only got 2 more slides left. So if you're really confused right now, then just stick with me for a little longer. Sorry, Jessica. I'm sorry that you're so bored. I promise there is a decent reason this is useful. And we're going to see part of it on the next slide. Okay. So the last thing we want to do before we get back to our original problems is write the following numbers as fractions of 100. So what is 25 as a fraction of 100?
25 over 100.
1/4.
Which reduces to 1/4, exactly. So 25 equals 100 times 1/4. 50 equals 100 times
Over
1/2.
1/2, yeah, and 1/2, yeah.
And 75 equals 100 times 3/4.
5 over
I
100.
put 50 as 2/4.
50 is 2/4. That works fine. I just reduced it to 1/2.
The most simple version of it is 1/2.
That's true. The most simple version of it is 1/2. Now, really quick, since these are just multiplications as fractions, what we can also do is make this into 25 equals 100 over 4. 50 equals 100 over 2. And 75 equals 300 over 4. Those are just similar things that we can use. I'm going to show you why it's useful on the next slide. So I'll give you just another second to write this down, and then we'll go into the last thing, I promise. It'll be super easy. It won't be super easy, but we'll be done at least. Goodness gracious. Now we're getting into all caps. Okay. Does anybody need more time here before we move on? Getting some blanks. So now what we're going to do is we're going to come back to our original problems. So we had these, we started these out. Yes, I can. Janie. Our original problems, we had these big numbers that you probably would never want to multiply in your head. But we're going to go ahead and try to do those right now. So we started out looking at 3,000 times 47. What is a way that we can break down 3,000?
3 times 100 times 100.
3 times 100 times 10 would work. And how could we break down 47? Uh-oh. 40 plus 7. Thank you, Candler. So we're going to ignore this. This says move our decimal place 2 to the right. This says move our decimal place 1 to the right. So we're going to do that at the end. We're going to move 3 places to the right. What is 3 times 40? 120. What is 3 times 7? Just 3 times 7, not 3 times 70. Yeah, 21. And 120 plus 21? 141. And then we're going to add in our 3 zeros. 0, 0, 0. There we go. 141,000. Okay. Now this last one, we're not going to worry about breaking down 2,468, but we are going to worry about breaking down 75. What did we just say 75 was as a fraction of 100?
25 or 1/4.
It is 1/4. Or 3/4, sorry. So what we basically have is times 100 times 3 divided by 4. So what we can do is break this down into 2, 4, 6, 8 times 100 times 3 all over 4. And we can divide 4 into this. Now there are tricks for dividing 4s that I'm not going to bother to show you guys today. But we can do pretty quickly. 4 goes into 68 17 times, and 4 goes into 2,400 600 times. So what we'll get is 617 times 100 times 3. And then we just have to multiply 617 times 3, which, again, a little bit complicated, but you'll get 1,851 times 100, or 185,100, so 185,100. Now, for the 18th time, if these tricks don't make a lot of sense to you, if this just seems like a more complicated way of doing something you already know how to do, don't bother with it. If some of these tricks seem like they could be really interesting or useful, then go ahead and use them. They will help you if you can learn them and master them, but it's not necessarily something you'll need. If you have any questions or if you want to stick around, feel free to do so. But otherwise, that's all I've got for you today. There's no new homework assignment. As long as you took your notes and you turn this in, you are good to go. There's not even a homework page on this set, so you're welcome to take off. Have a good rest of your day, and I will see you all tomorrow.